Okay, so any questions on the homework you guys want to ask about? Julia, go ahead. Yeah. The funny one, this one, yeah. These should be if you partition it correctly. So let me show you how I partition it. It should be spot on. Um, so for example, notice I'm drawing a rectangle like this. And unfortunately, I already did this, so I have it memorized. So if I look at that rectangle, how wide is it?
5.
And how tall is it? So that's 35. Then you can make another rectangle. How wide is that guy? And how tall? So it's 12. And there's still more. That's 47 so far. Then we got 3 triangles left, right? We got this itsy bitsy one over here. What it's half of a square, right? Or it's 1 and 1, but half of base times height. So that's 0.5. Then I got this one pointing down, which is a base of 4 and a height of 1. So that's 2. And last, I have this right triangle, which looks like a height of 6 and a base of 2. So that's 6. So I get 12.5. Nope, 8.5. So when I add them up, I should get 55.5 spot on. So it should be spot on. And then this one here, hopefully you guys did this. That'd probably be the best way to do it. You can do that too, if you want. Yeah, because you have a bunch of half triangles and whatnot. What we will do eventually when we this is not until second semester. We'll put a center and we'll draw triangles each corner and we'll find the area of those triangles. That's a technique we'll talk about later in the year. That's another way you could approach it. And you can do this for any polygon, pentagons, hexagons, 7, 8-sided gons. So, okay, for actually, I thought it was factoring. Never mind. 129, you guys okay with that, or the other problems? How about 127? Was that fine? Did you guys see the pattern? As X went down, Y also went down by 1. Yeah, this is all review. And then the second set, any questions on the second set at all that you guys want to ask about? No, we're okay. All right. Really quickly for the quiz, just so you guys are aware of what I'm going to be asking you. I will ask you to factor. So let me just make up a problem right now. Uh, trying to think here. Think of a good one. Okay, I got one. Okay, so I asked you to factor this. So this is from the summer assignment. I like to do a diamond. You guys are probably familiar with that technique. And I identify A and C. A is a leading coefficient, C is a constant. What's my leading coefficient here? And what's my constant? So I multiply, I get 12. And then my middle term B, I put it down here. My goal is to find two numbers that multiply to the top and add to the bottom. So multiply 12, add to 7. What two numbers would that be? Good, Nick?
4 and 3.
4 and 3, perfect. Now, be careful, because some people will say, oh, it's x plus 3 times x plus 4. But that wouldn't make sense, because if I multiply that out, I get x squared, not 2x squared, right? And 3 times 4 is 12. That doesn't make sense. Now, if the leading term was this, if it was like that, then go for it. Then you could just say, yeah, x plus whatever, right? But it's not. So instead, this is what perhaps you did this in Mr. Donahoe, Ms. Langston's class, if you're a sophomore, or if you came from a middle school, if you had like Ms. Herman or Ms. Ramey, or I can't remember who else teaches there. Um, you did something like this, where I put the leading term in the upper left corner and the constant in the lower right corner. And then the 7x, why did I do the diamond? Because I split the 7x into two, 3x and 4x. That's called splitting the middle term. So I put 3x and 4x into other corners. I do this as a guide to help my factoring. Look at the first row. What's common between those two terms in the first row? More than that.
Yeah.
2x. Right? Then what do I multiply 2x to get to 2x squared? Right. And then what do I multiply x to get to 3x? What do I multiply 3 to get 6? Done. Factored. 2x plus 3, x plus 2. So I'm definitely going to ask that. So that's just something that we want to be very comfortable with. And if you were to work it out, you get back to the original. Nick, go ahead.
We don't have to like solve. Do we have to solve for that?
No, I'm not asking to. If I did, you go obviously a step further and set equals 0 and tell me what each factor, because anything times 0 is 0. So what makes 2x plus 3 0? What makes x plus 2 0? That'd be -3/2 and -2, but I'm not asking that. Just asking to factor straight up. That's all. So hopefully that is okay. Another one would be like, say I give you 2 points. And I ask you to find the equation line that passes those 2 points. So y equals mx plus b. Hopefully you guys remember that. Now, how would I find the slope? Yeah, go ahead, Anthony. Or yeah, or delta, yeah, change y or change at x, or rise or run. So 4 minus 2 over 1 minus -3. However order you subtract it, if you did 2 minus 4, then do -3 minus 1. I don't care. Just make sure you're consistent. That's 2/4, should be 1/2, right? So I'm halfway there. Y equals 1/2 x plus b. Well, how do I find b? What would I do to find b? Remember your name? Is it Griffin? Pierce, sorry. Your Griffin's over there. Sorry, yes. Yeah, just plug in one of the points. So like say plug in 1 and 4, and then solve for b. B should be, I think, 3.5. So the equation would be y equals half x plus 3.5. So just find slope, work it out. That's all. And the last part, I don't know how complex it is. I have to look at the quiz again. And I wrote 5 different versions of it, so I don't remember precisely. But what if I had this here? Okay. I think I don't know. Maybe it's easier in the quiz. But if you could do this, you could do the easy ones also. This is a little more challenging. So you want to solve for x. Where do you see x? On both sides. So we should collect them. We should get all the x's on one side first. So I'll move the x from right to left and the b from left to right. Now, why did I do that? What can I factor out from the left side? The x, right? And then what do I divide by? The n minus 1. Is x by itself? You bet. Now, what if I didn't have x twice? What if that was like some random letter like a? Then fine. Subtract the b. And then what would you have if I subtract the b? Divide by n, exactly. Yeah, I just subtract the b and divide by n, and x is now isolated. So the whole point's to isolate. That's what we're trying to teach you guys, because it is a skill that needs to be pretty rock solid by the time you get to Algebra 2. So we don't want to just keep reinforcing this. So yeah, so that's what's happening there. So that's going to be the quiz, which we'll do in probably 20-ish minutes from now. Any questions? Cool. Let's get moving to notes in. So the notes are pretty short today, 3 pages. It's on a concept called reflection. But before we get to that, we do need to talk about visualization. How do we spatially visualize geometric shapes? 3-dimensionally is going to be a big way of seeing this. So we're going to kind of take a step back and kind of take a look at what's happening with 147, which is something called a net. I'm guessing call it a net because, I don't know, maybe you have like a piece of cardboard and it's kind of all splayed out and something net that you can sort of just bend. I don't know if that makes any sense, but here's the thing. We're trying to make a box out of this, right? That's what you're trying to do. Try to make a box out of this. If you have a box that's closed, it has a lid as well. So not an open air box, a closed box. How many faces would it have? You had a box. How many faces would it? We have 6 faces, yeah. You have front, back, left, right, top, bottom, right? So it would look kind of like this. You need to have 6 faces. And if it's a cube, by the way, then all the faces are shape of a square. Usually when I draw a cube, we'll draw 2 squares off-centered and then connect the corners like that. So we're trying to create that. So you need 6 faces. Well, how many faces do they have?
5.
How many does C have? That's kind of a problem, right? You need to have 6 faces if you want this to be completely closed. So I would say no for A and C. So the net is basically the box all splayed out. If you kind of like, I don't know, got a present or Amazon, whatever, you open the box and you cut it down some of the sides, whatever, or creases, and splay it out like that. You want to be able to fold it back to a box. A and C would not get you a closed box with a lid. Just wouldn't, because you don't have enough faces. Because 5 faces here, 5 faces here. Now, how many faces do B and D have?
Six.
Okay, so we're okay. One thing you have to be mindful about is, can you fold it? This is the part that's a little tricky. It's a little mind bending. You have to visualize it three-dimensionally. Can I fold these squares in such a way to form a box like I did to the left? The answer will be yes. We will be able to. Mainly because I could probably take this flap and bring it to the front, and then these kind of like go around, and then this will close it off, this last flap. We're here. Yeah, I could kind of like fold these and then fold these in. And it's kind of hard to tell, like it's like I'm coming out of the board. So yeah, both those are fine. Now, but just because you have 6 does not necessarily mean it can make a box. For example, if I had this here, without cutting any squares out, can I fold that to make? No, just because the way it's set up, right? So you would need like at least kind of like a string of like 4, I guess, in a row to make that work. Those just to get you thinking visually. That's the whole point of that exercise. It's not something we really spend much time on. What we do care about is the stuff afterwards about reflection. Reflection is going to be a big part today. So, say for example, you wrote down these words and you put them in front of a mirror. And usually when you look at the words, they should be reversed, right? But what happens with one of these words? One of these won't be reversed. Which one would it be?
What?
Yeah. So if you think about it, this right here, this looks different. This will be a different observation compared to A and B. So these, all of them will be reversed, but this will still look the same. That would look the same because each letter has something we call symmetry. Think about it. If I take the letter W and draw a line right through the middle of it, did I cut that precisely in half? Yeah, same thing with the O. What other letters would do that? Do you guys think? O. O, what else? M, T, what else? A, U, if you don't do a little X, B, H, I think that's it. K, if you did it that way. Yeah. So, but anyway, you get the idea. Or B, if you did it horizontally. C, if you did it horizontally. So yeah. So we're looking at symmetry, but A and B here will look different. Yeah, that'd be O, E, G, and the E would be reversed, and the G would be reversed. This would be like, it's spelled like rats, but R would be reversed also. So these would be reversed. They would look weird. They'd be really strange for A and B. So you just want to kind of think about that for a little bit, like in terms of reflections. Okay, now let's move on to 149. For 149, you have a triangle on a flagpole, and you decide to rotate it 360 degrees. So this will be rotated like that. If you think about it, what kind of three-dimensional shape would I be generating if I did a cone? Yes, 100%. It'd be like an ice cream cone. Yep, you're totally generating a cone. Yeah, like back in the day before, like if you had on water bottles, you go to a water cooler, you have like these paper cups, and the paper cups would be shaped like a cone. And that's essentially what you have a triangle that you would rotate 360 degrees. Now we have our own little water bottles, not paper cups, but yeah, you form a cone if you took a triangle. What if it was rectangular and I rotate at 360? What do you guys think that would generate? A cylinder, yeah, like a can. Okay, now think about this one. Let's say I want to get a sphere. So a sphere is like a ball. or a globe?
Like a half circle.
Yeah. Yep. Good. You guys are on fire today. Awesome. Look at that. Yeah, totally. Semicircle. Took a semicircle and rotated it. You form a sphere. Okay. So questions? Good. Okay. So now this is the part where we're going to start doing some group work. Now you guys are warmed up a little bit. We'll do A together, but B and 51, I'll have you guys try. And then we'll come back and do 52 together, and the notes will be wrapped up. So for 50, so we're talking about reflections, right? So you hear this, you see a snowman, right? So there's a snowman, and the dashed line in between is what we call line of reflection. So the image is on the right side. So why do you think we call it a reflection? Because it's like a mirror, right? They're mirror images of each other. That's what they are. They're mirror images of each other. Basically, everything flips. Every feature flips from left to right and right to left. So take a look at the carrot. That's pointing to the right. That's pointing to the left. Look at the star. See how like the longer part is that way. Now it's the other way. Look at its belly, the whatever you put there. It's reversed, right? Everything is flipped. That's precisely what we're going to do in part B. Now, those little red things, yeah, the tail in the back, I'm sorry, you guys don't have it. That's something you can use to help you with the next exercise of part B. So the way it works, and it's kind of hard for me to demonstrate it for everybody, but if you take this and put it like right here, and if you kind of look above this, you'll see the reflection on the other side. Actually, can I? Oh no, it's kind of hard to actually. I can see it right now. Yeah. So then what you do is you draw the reflection on the other side. So you can use this to help you. We're supposed to have 7 of these, but there's no geo class going on right now, and so we're kind of short. But you can also just kind of tell, like for example, like this corner here, how far is it away from this line of reflection? So go 2 this way. This obviously sits on it. This is like a little further away. So you can kind of maybe do it without this, but this is kind of nice because if you do put it right here and put your head right above this red thing, you should be able to see the reflection. You can trace it on the plate. So go ahead and try that. I'll show you guys the answer in a moment. And try to compare. But we're just reflecting. We're jumping points along the reflection line. So the points are jumping. So we're going to give it a try, and then I'll show you guys the answers in a moment.
You guys can try.
Hey. Correct. Yeah, so this little thing is not going that way. Yeah, everything's reversed. So if anyone wants to see this in action.
No, we're supposed to do all of them.
Yeah, it's kind of, how are you?
So, like,
Yeah, I guess, yeah.
yeah, so like, I'm looking at this object, and I can see the reflection on the other side. Then take my pencil. Actually, hold on, I might need to do it this way. Okay. So let me do this. So can you see the reflection? Yeah, so then I take my pencil and trace this. You don't want that one. That's a good, yeah, if you want it. If yours looks like you got figured out. Sure, yeah, let's start to trace it. Like, yeah, that's what. Yeah, you kind of got it. I'll wait till Pierce is done. So you could do. Yeah. So here's the actual image. And probably now you can probably see the very image on the other side, and you take your pencil. Yeah, so what you want to do is you want to view the actual image on, you want the actual image on your side. And then you'll see the reflection on the other side of the red reflector thingy. So that's what that's happening. Oh.
What? Yeah. Are you not supposed to draw the same shape?
Should be reversed.
Yeah, yeah, yeah. Oh, yeah. That's reversed.
I think I'm doing it right.
The reflections have to be like exactly on the lines and stuff.
Be pretty darn close. Okay, I made that a little too big, actually. That was terrible. Let's try again. I do have the actual answer. I just wanted to see if I could do this by hand. That's a little better. Yeah, I think that makes sense. Okay, I'm just gonna so let me show the answer key. It's a little easier if you have that reflector, if we don't have enough of them. So here we go. So the first one, notice that this little notch is pointing to the left, now the notch is pointing to the right. And notice how like it's like straight here, straight there, bent there, everything's reversed. So that. This one, it's like a little, looks like a little like spaceship or a Cybertruck or something like that, kind of shape like that. So you flip it over, get that there. This is just a weird looking arrow. So that's where the reflector really helps. If you have the reflection, you can view this image on one side and see the reflection on the other side. That one should be it's an L shape, so it should be like a T afterwards. And just leave it alone. So already it is what it is. This one, the rectangle gets rotated in a way. That's kind of what's happening. And the whole point of this is if you cut out a piece of paper, a square piece of paper, fold along the dashed line, what would happen to these two images? They map, right? Yeah, they just map onto each other exact time. That's what would happen. So, yeah. Cool. So let's keep moving. Okay. Any questions? All right. What do you guys say for 51? I won't show the answer just yet. Like, for number one, are those reflections of each other? Yeah. Again, if I were to cut out a square piece of paper and fold along that line, the two lightning bolts would map onto each other. There's only one other diagram that shows reflection. What would that be?
4.
Correct. The hearts would actually map onto each other. Now, do you guys see why the leaves would not?
Yeah.
And the funny face would not either. That has to be reversed. So that's no and no. Yep. Okay. So the last part is a part what we really want to be present to. This is all about coordinate geometry. It's a big deal. We really got to understand how reflection works with coordinate geometry. So what we're going to do, I'm going to have you guys do some groups. I'll walk around and help you guys out. We're going to fill out this table. We're going to plot the points. I'm going to ask you guys to make a reflection about this along y equals x. Now, y equals x, what's the y-intercept of y equals x? What would it cross the y-axis? What if we put in 0 for x? What's y equal? No, sorry, I meant for y equals x. No wonder you guys are confused. You guys thought I was asking something else. 0, right? My apologies. So for y equals x, it would be right here. And so of course you'd have a bunch of dots like this. So we're going to graph a dashed line like that. And that's going to be our reflection line. I think I've done that. I kind of messed that one up. Let's try again. Yeah, it doesn't it helps me you have steady your hands. Okay. So what I want you guys to do is fill out the table for part B. Then afterwards, reflect it about the dashed line. And then we're gonna have an observation about it at the end. So go and try it right now. I'll come around and help you guys out. Where's my water bottle? Oh. Yeah, make sure you plug order of operations correctly. When you play -3, what's y equal? 12. Yep. -3 squared is 9. Remember, you gotta do -3 times -3 first, then add 3. So you should get -3 comma 12. I'm gonna switch to green. When you play -2, what do you get?
7.
-1? 0? And how will the other numbers look? Yep. It's there's a sense of symmetry there for sure. So you plot your points. Now, if we're very careful here, we have 7 points. Each of those 7 points is reflective about that red dashed line. So if I have a point at 0, 3, what's going to be the reflection of 0, 3 on the other side?
3.
Yeah, 3, 0. Because you want to maintain the same distance. So we'll go light blue. Thank you, Emily. So 3, 0. Let's look at 1, 4. Where do you think 1, 4 is going to be on the other side? 4, 1. Now you get the pattern. 2, 7. Where would 2, 7 be on the other side? 7, 2. Good. Awesome. And then, of course, naturally we'd see something at 12, 3. So what's happening? These all map onto each other. Notice how the red line's going right through the middle of all that. Okay, and then likewise for the other points, right? If you have -1, 4, 4, -1. -2, 7, 7, -2. -3, 12, 12, -3. So you form a sideways parabola. So now take a look. If I were to cut this out and flow along the red line with the green and blue, they'd map on 100%. So what does this tell me? What this tells me is that when you do a reflection, so for the last part, they're asking you to state the coordinates of your reflection, which is pretty obvious: 12, -3, 7, -2, 4, -1, 3, 0, 4, 1, 7, 2, 12, 3. What this tells me is that when there's a reflection, this is the observation we make. We'll talk more about other shifts and transformations down the road. When there's reflection, how are X and Y related? What do you do to X and Y? You swap them. You switch them. That's it. A swap will create a reflection. 100%. And I think that pretty much covers. Yeah. Okay, perfect timing. So we're gonna start the quiz. Honestly, I don't think you need a half hour to do it. I think you get done in 4 or 5 minutes. If you need 10, 15 minutes, so be it. That's fine. That's not a problem because some people get extended time. But once you're done, then I want you to go back to this packet that we started on Friday. I think you guys got to about page 5 or 6 and keep working on that. And then once your other table mates are done, you guys can all like talk and work through it. The answer key, I think I haven't schooled you. I could double check, but I do have the answer key up here. But I want you guys to keep working through this. And if we don't finish today, it's okay. We could do more of it on Wednesday. Just homework's already been posted to Schoology as well, so you have that to work on. But I'd prefer you work on this after you finish the quiz. So, okay. Any other questions? All right, let's get started. Let's do the quiz. Have them right here.
What should we do with our homework?
Hold on to it. Then you always have a copy of it. That's what you guys know online for voice so great. So that way you also have this. And just one side. If you want to use Capco, you can. Those are committed. I have those 4 punch ones that can bring out.